right, let's go ahead and get started on this. On the first one, following my flow chart, the first thing it tells me to do is to simplify it if I can, and this is already simplified. So I'm going to go ahead and go straight to my perfect radical and my not perfect radical. And in the perfect radical, the 8 is perfect, the x cubed is perfect, the y to the 6 is perfect, and of the z, 3 of the z's are perfect and 1 is not. So I'm just breaking up my 4 z's into the 3 z's in the first radical and the other z in the second radical. And now I'm going to go ahead and take out everything perfect. So using my exponent table, the cubed root of 8 is 2, x cubed becomes x, y to the 6 becomes y squared, z cubed becomes z, and the other z will just stay in there as my not perfect. All right, let's go to the second one. What I'm going to go ahead and do is, since they are two um, radicals, I'm going to simplify into 1 because 16 and 8 are not perfect. So I'm going to multiply the 16 and 8, and that becomes the fifth root of 128. And now what I'm going to do is use my prime factorization, and I'm going to start looking for the prime numbers that make up 128. So starting, I get 2 and 64, and at this point I'm just going to walk through this and not talk. So 128 is broken down into a bunch of 2's, and when I count, there's actually 7 2's. So what I'm going to do is rewrite this fifth root of 128 as the fifth root of 2 to the 7th, and I'm going to break it into the perfect and the not perfect. So of my 7 2's, 5 of them will be perfect, 2 of them won't, and then the fifth root of 2 to the 5th is just 2, and then that 2 squared that I'm circling right now, that's worth 4, so I'm just going to go ahead and turn that back into 4. And there's number 2. Number 3, in order to add and subtract, what I need is for my radicals to be the same, because adding and subtracting is very picky. So what I'm going to do is the 5 is already a prime number, so that's simplified as it can go. The 45, I'm going to use my prime number chart that we've been doing, so here we go. And I'm going to rewrite 45 as 2 3's and a 5. And I'm going to go ahead and rewrite the 1 for the fifth root of 5. And now the fifth root of 5 can just stay that way. But when I go to the square root, the other one, the 3 squared and the 5, the square root of 3 squared is 3. So that comes out, and then the 5 will just stay in there. And now I can ask myself, how many square roots of 5 do I have? I start out with 5. I take away 3, so when I'm done, I have 2 of those square roots of 5. Okay? All right, let's go to the next row. The first thing I'm going to look is anything perfect. 27 and 9, nor any of the x's are perfect. Since they're both in the fifth root, I'm going to go ahead and simplify it and multiply my 27 and my 9 into 343. And my x's become x to the fifth. And then when I look, 243, that is perfect. So that can come out, and so can x to the fifth. So the fifth root of 243 is x, and the fifth root of x to the fifth is just x. So there's number 4. Number 3, it's already under one radical, so what I'm going to go ahead and do is just look to see is anything perfect. 63 is perfect. So what I'll do is make up my perfect radical and my not perfect radical, and the 64 will go in there. 3 of the x's will go in there, and 1 of the x's will be in the non-perfect. And there aren't enough y's to come out, so they'll go in the not perfect. So at this point, the cubed root of 64 is 4. The cubed root of x cubed is x. So that comes out, and then the rest of the not perfect stuff just stays in there. So when we're done, there's number 5. All right, number 6. The R there again indicates that it's going to be rationalized at the end, but what I want to do first is before I go straight to taking perfect stuff out, my biggest suggestion is simplify it. Just like we simplified on 4, we multiplied everything. What I'm going to do is when I look at 6, I want to see, can I simplify 18 and 49? Can I simplify simplify the x's, and the y and z, there's only one set of them, so I won't simplify those. So with 18 and 49, I, I can't simplify those. So those are going to stay as 18 and 49. My x's can become x to the fourth in the top. I will still have the y to the fourth in the top and the z cubed in the bottom. So at this point, everything's in a square root. Now I want to look what's perfect. And I'm just going to notice it. I'm not going to do anything with it right now. Right now, the 49 is perfect, and so are the x and the y's. So I will leave them for now, but my issue is with the z cubed. I need to build up my denominator. I need to rationalize it. And the 18, can I take out any of the 18? So I'm actually going to start with the 18. What I'm going to do first is do my little prime factor thing. I'm going to do it right above it. So here we go. And I'm going to rewrite 18 as 2 3's and a 2. I am still leaving in the x to the fourth and the y to the fourth. I'm still leaving in the 49, and I'm still leaving in the z cubed, and this is all in a square root. So I've taken a better look, and now what I notice is perfect is the 3 will be perfect, the x, the y, and the 49. So at this point, I just need to rationalize the denominators. So when I rationalize the denominator, the only thing that I need to fix are the z's. I have 3 z's. I actually need a total of 4 in order for the z's to be perfect. So I'm going to build up my fraction with one more z, because that will give me 4 z's. All right, so I'm going to continue my work down to the next line. In my denominator, just building up my denominator, I now have my perfect 49 and a perfect z to the fourth. In my numerator, what I'm going to do is just clean it up, put it all under one radical, so I still have the 3 squared, I still have the 2. I have my x to the fourth and the y to the fourth, and now I have a z, and now I'm ready to take the perfect stuff out of everything. So again, the 49 is now perfect. The square root of 49 is 7. The z to the fourth is perfect. That's z to the squared. In the numerator, we had said the 3 squared is perfect. The square root of 3 squared is 3. Um, the 2 is not perfect, so that will be staying in there. So I'm going to go ahead and make my not perfect bracket over there. And the x to the fourth and the y to the fourth are perfect. They'll come out as x squared and y squared. So when I'm done, this is my final answer for number 6. All right, 7. So on 7, I also have a fraction. But again, I'm going to simplify it first. I'm going to see what I can divide because they're both square roots. So the 12 and the 3, they can actually divide into 4 and the x squared. And now when I look, these are both perfect. The square root of 4 is 2. The square root of x squared is x. So there's 7. Number 8, kind of like number 6, probably not as tough though. The first thing I want to do is, can I simplify first? The 5 and the 27, I can't simplify. The x cubed is in the denominator. So what I'm going to do is go ahead and prime factorization, or use that process for my numbers. 5 is already primed, so I'm just going to do that process with 27. And I'm going to rewrite 27 as 3 3's, 3 cubed. So here's my numerator still, and here's my denominator. And now what I can do, if I want, is I can actually just make it one big fifth root. You don't have to, but you can. So now what I'm going to do is, nothing's perfect. I can't take anything out. The only thing I have left to do is rationalize. So what I'm going to do is put my extra fifth root here to rationalize with, and I'm going to build up the 3 in the denominator and the x. So with the 3's, I have 3 3's. I need a total of 5, so I'm going to add 2 more 3's. And with the x's, it's the same thing. I have 3 x's. I need 5, so I'm going to add 2 more. And now just bringing the denominator along, that gives me 5 3's, so 3 to the 5th, and 5 x's, x to the 5th. My numerator, I'm just going to put it all under one radical. So this 3 squared and the 5, I'll just bring along for now, along with the x squared. And now the denominator, everything's perfect. The fifth root of 3 to the 5th is 3. The fifth root of x to the 5th is x. And as far as the numerator goes, because we did all our simplifying already, I'm just going to clean this up. The x squared will still be there, but the 3 squared that I'm circling right now, that's worth 9, and 9 times 5 is 45. And that, is, again, is all in the fifth root. And that's it. You will not be able to simplify any further because we took care of all possible simplifying earlier. So that's 9. Or I'm sorry, that's 8. 9, I'm going to put 9 in blue below it. I didn't quite put it in the right spot for the other one, so here we go. The first thing I'm going to do on 9 is, since they're both square roots, so here's number 9, I'm going to put it into 1 square root. So I'm going to combine my x's. That gives me 4 x's, 5 y's, and 5 z's. And what I notice is perfect are the x's. I'm going to go ahead and split up my perfect and my not perfect. So my x's are perfect. Of my 5 z's, 4 of them are perfect, 1 of them's not. And of my 5 z's, the same thing. 4 are perfect and 1's not. So now I'm going to take all the perfect out. The fourth root, or the square root of x to the fourth, is x squared. Same with the y and the z. My perfect stuff is out, and not perfect will be y and z still stuck in there. Okay, that's number 9. All right, let's continue on to number 10. So in the next 2 rows, we're working with exponents. Don't let the fractions scare you. Just ask yourself, should I add the exponents, subtract them, or multiply them? Otherwise, we're doing the same things that we did before. If we have parentheses, we want to multiply our exponents in, and then we want to organize if we can. So group your numbers, your A's, your B's, your X's, your Y's, whatever they are, and as you group them, or after you group them, then would you add or subtract those exponents? So on number 10, I see parentheses. The parentheses tell me I should multiply the exponents, so I'm going to do that. And then the negative exponents tell me to move it to the top. So when I'm done moving it to the top, I get x to the 2/3, and that's it for that one. Next problem. So when I look at this one, I see parentheses, and again, all the parentheses are asking me to do is to distribute that exponent in. So I'm going to distribute the 25 to the 1/2. I'm going to distribute it to the a. I'm just multiplying my exponents into the b. 25 to the 1/2, I want you guys to recognize that a 1/2 is like a square root, and 25 to the 1/2, where the square root of 25 is 5. My a becomes a to the 5th, and the b becomes b to the 8th, because 16 over 2 is 8, and 10 over 2 is worth 5. So that's 11. 12, this is just like everything that we've done in the past. I'm going to organize. So I'm going to put my numbers together. I'm going to put my x's together. And I'm going to put all my y's together. And nothing is moving because there are no negative exponents. So as far as my answer goes, the 12 over 2 turns into a 6. I end up having 6 x's because I add the exponents. And in the y's, these y's cancel out, so I'm just left with the y squared on the bottom. And that's number 12. All right, 13. I see parentheses. That means I should distribute my exponent to everything in there. So it goes to each of those. So the 3 gets the 1/2. The x to the negative 2nd is multiplied by a 1/2, and the y to the 4th is multiplied by a 1/2. And then I'm going to organize. Again, a 1/2 to the 3 is like a square root of 3, but that doesn't have a perfect square root, so I'll just leave it like that. My x becomes an x to the negative 1st, which says it moves to the bottom. And then my y to the 4/2 is just y squared. So there's 13. 14. So on 14, I do see parentheses, but I don't need those parentheses really, because there isn't anything on the outside. So what I'm going to do is just multiply the things that are alike. So I'm going to organize actually. I'm going to put my numbers together. I'm going to put my m's together. And I'm going to put my n's together. And since nothing is negative, it all just stays in the numerator. So putting my answer together, 2 and 8 is 16. For my m's, I should add the exponents, and 1/2 and 3 3/5 when I add them up as a common denominator, that would be 10. So this one becomes 5/10, and this one becomes 4/10. So when I add them up, I get n to the 9/10. On the ends, 3/4 and 1. So as a common denominator, I can turn 1 into 4/4. I get n to the 7/4. And again, you guys, on this, um, you can use your calculator to add the 1/2 and the 2/5 and the 3/4 and the 1 if you need it. All right, last problem, 15. And then I'm going to stop the video and I will start a new video for the back page because for some people that's the only objective they actually have to take care of. So on 15, I see an exponent on the outside. I'm going to distribute that 3 to everything. So I'm first going to start with the numerator. So I'm going to distribute the 3, or the square to the 3, to the x. And I'm just multiplying my exponents, the y and the z. And then I'm going to distribute to everything in the denominator. So it's going to go to the 2, it's going to go to the x, and it's going to go to the y. And it is pretty well organized, actually. I mean, if you notice, all my numbers are together, all my x's are together, my y's, and the z doesn't have anything to pair up with. But 3 squared, I'm going to turn into 9. 2 squared, I'm going to turn into 4. And I can't simplify 9/4. X to the 2/4, let's take x to the 1/2 with x squared. Y to the 4/3 with just y. That's 2/2 is just y to the first, and then the z squared. And now when I clean it up again, as I already said, 9/4 doesn't change. At this point, I'll be subtracting the exponents. So 1/2 minus 2 is on the calculator. All right, so sorry, going back to this. 1/2 minus 2 is -3/2, which starts out in the top, but that negative exponent says it's going to move to the bottom. On my y's, 4/3 minus 1, that's y to the 1/3, that's going to be in the top. And then my z will stay in the top. So again, you guys, I just let my calculator subtract 1/2 minus 2, and I let it subtract 4/3 minus 1. And if you got a negative exponent, it will move it to the bottom, and the positive exponent will stay on the top. And that is it for the first page. So if you want to see the second page, that will be a different video.